trigonometry and developing and applying the cosine law. So let's consider the example. Solve triangle ABC given angle A is 95 degrees, B is 5 centimeters, and C is 3 centimeters. Where necessary, side lengths should be correct to one decimal place and angles to the nearest degree. So we're going to highlight our key information, all the information that's going to help us solve it. And we need to think about what am I actually looking for. I'm trying to solve. That tells me to find all my missing pieces of information. So whatever angles and side lengths I don't know. I know how to do this. I draw my picture, label my triangle, being careful to use capitals for my angles. Insert the information I know. Angle A is 95, side B is 5 centimeters, and it's opposite angle B. And side C is 3 centimeters, and it's opposite angle C. Now it's not a right triangle, so I know I can't use SOHCAHTOA, so I'm going to try my sine law. And I write my sine law out. Sine A over A is sine B over B equals sine C over C. This is all very exciting. Right, Mrs. Kadai? Say yes. She nodded. She's not even going to try and contribute to the lesson. I don't know. Sine 95 over A is sine, I don't know B. I don't know how to find B because I only know one angle, but I do know side B is 5. And I don't know angle C, but I do know side C. Now the problem with this is none of them, I have an unknown in each ratio of the proportion. I can't solve this. So what do? That's where I need to work on developing my cosine law. And the cosine law is going to work exactly the same way as the sine law did to develop it. We're going to label the 3 vertices of the triangle A, B, and C. Okay, so same as we did with finding the sine law yesterday, or deriving the sine law, we're going to draw perpendicular from vertex B to side AC, and we're going to call it side H for height. The horizontal distance from vertex A to side H is x, so we're going to call this little bit of distance here x. This is pretty easy so far. And we're going to call this distance here b minus x, because the whole side has a length of b. Any relationships that exist between the sides of the 2 triangles, or the 2 right triangles. Sorry, I missed the word right triangles. So that's pretty straightforward too. If I look at this, I've got h squared, I should label this as a. I've got a squared is h squared plus b minus x squared. And in the other triangle, we have side c squared is equal to h squared plus x squared. So what does that look like? It looks like this. C squared is x squared plus h squared. And in the right triangle, a squared is b minus x all squared plus h squared. And if I expand b minus x squared, because it is a square of a binomial, it becomes b squared minus 2bx plus x squared plus h squared. Well, that just looks like a bunch of mess to me so far. How is that going to help me get to the cosine law? Now I've added not one extra variable like I did yesterday with the sine law, I've added 2 extra variables. Mrs. Kadai is insistent on disrupting our lesson today. I just thought I'd tell you that. So, how can we relate all of these equations? Oh, and I forgot to go do a relationship. I missed this step. How did I miss that step? If I look, I've got some cosine ratios I could use that incorporate side H. Cos C is, no I don't. What am I doing? I'm confused for a minute. Cos C is b minus x over a. Yes, I do. Sorry, I got confused for a minute. And I have cos A is x over c. We want to use cosine law. We want to develop the cosine law. So we're not going to worry about that h and try and come up with a relationship using SOHCAHTOA or the primary trig ratios for it. So I've got 3 statements here. I could also have written this cos C equals b minus x over a on the next page, but I'm not actually going to use it, so I ignored it. If I look at these 3 equations that we created, what can I do to make this first equation look a little bit cleaner? Well, if I look, x squared and h squared, well, those two are the same as c squared, aren't they? So that would probably be my first thing. Now the thing I want to deal with is getting rid of those the x's and the h's. So that got rid of one of them, and it gave me c aside in the triangle. So if I work with that, I'm good so far. Now, I want to get rid of this x. Well, wait a minute. X is c cos A. So I can substitute that in for the x. And now if I look at this, I have a lovely equation that involves the 3 side lengths and one of the angles. That is in fact your cosine law. And it doesn't matter what we name the sides. We can rearrange it and say a squared is b squared plus c squared minus 2bc cos A. The key is this side here is opposite the angle used in the cosine law. So it doesn't matter what we order, what we label the triangle. The 2 other sides we know are the 2 that appear on that side of the cosine law. When can I use the cosine law? Well, obviously, if I have 2 sides and the angle opposite the side we're solving for, and if I look at that, that's angle A, angle B, angle C. If I have side B, side C, I can solve for side A, and it's opposite angle A, and angle A is in between the 2 sides we know. So that's referred to as a contained angle. The other thing we can do is if I know A, B, and C, if I look, I'm left with one unknown in the equation. And that tells me I can also use the cosine law. So if I go back to this lovely question here that would not work with the sine law, I have 2 sides and the angle in between them, known as a contained angle. That tells me right off the bat that I can use the cosine law to solve for side A. So I can say a squared is b squared plus c squared minus 2bc cos of angle A. So a squared is 5 squared plus 3 squared minus 2 times 5 times 3 times the cos of angle A. And I have to follow my good friend BEDMAS. So 25 plus 9, I'm doing my exponents first. Then multiplication occurs. 2 times 5 times 3 is 30 cos A. And then a squared is 34 minus 30 cos. Oh, and I forgot to substitute in A, which is 95 degrees. Now, when I use my calculator, I need to be really careful because if I'm not careful, I will end up with errors. So 34 minus 30 cos 95, I have to square root both sides. And obviously, I made a mistake here and I shouldn't have my exponent. I'm not subtracting 34 or 30 from 34 because there is multiplication between this 30 and the cos 95. So I have to deal with that first. And I'm going to use my handy dandy calculator for that. I have to evaluate the cos 95. I don't erase that number or round it. Then I multiply by 30 on my calculator. And then I figure out how my calculator works. And I add that number to 34. And I square root and I round to 6.1. Now I know a complete sine ratio here because I know these values here. And you'll notice right here, I went back to putting in the exact value using the square root sign for side A. That way, when I substitute in and solve for angle B or angle C using the sine law, then I'm working with an exact value and I don't have rounding errors. So we're going to start with angle B. And we're going to sine 95 over that big mess under the root sign is equal to sine B over 5. I'm multiplying both sides by 5 times the square root of 34 minus 30 cos of 95 because in order to solve a proportion, I have to multiply both sides by both denominators. And in order to get sine of angle B by itself, I need to divide both sides by this square root of 34 minus 30 cos 95. And I have this ugly mess on my screen. And I have to take the inverse sine of that. So before I do any math, I've just rearranged my entire equation to isolate for B. Now that I've done that, I can get my handy dandy calculator out again and evaluate. And if you do not get this answer when you try to evaluate this on your handy dandy calculator, you need to come and see me and ask me how to use your calculator. So now we know angle B has a value of 55 degrees, and all that's left, we've added angle B to our diagram, is to find angle C. And we know from the angle sum of a triangle theorem that we simply have to subtract angle B and angle A from 180 degrees to get angle C. Or we can substitute them in, angle A plus angle B plus angle C is 180, and solve the equation. Finally, homework before you come to class, exercise 5, pages 9 to 10, number 1.